Hello, ladies and gentlemen. This is Ricky Chen, FAE with ITG Electronics. Today we will introduce and try to understand about TLVR. TLVR is a short form of Trans Inductance Voltage Regulator. But why and what is the advantage of using TLVR? Here as the picture shows on the left, TLVR has two coils, a primary coil and secondary coil. The concept is that secondary windings are connected in series with a compensation inductor LC, which is used to set the effective coupling between all phases to transform the energy from the secondary back to the primary windings. This will improve the ultra-fast transient response due to reducing the effective output inductance of the power train. What is the advantage and the disadvantage of TLVR? Now we know the main purpose for TLVR is to improve the transient response and increase the total efficiency of the project. But what will be the pros and cons for TLVR? First, for the advantage, using TLVR topology will reduce the output capacitance and improve the BOM cost of platforms. Up to 50% less output capacitance can be achieved with TLVR versus the traditional bulk design. Second, TLVR allows higher OCL in the primary windings by reducing the switching frequency at the same time, which will reduce the switching loss and increase the total efficiency of the project. Third, it is able to improve the ultra-fast transient response capability. Its cons will be higher cost on inductor by itself, since this is a coupled inductor. But due to the capacitor reducing, it will still save on the overall BOM cost. Second, TLVR is harder to get repaired once it has a problem, and higher risk with EMI issue. Now let's talk about the code layout for TLVR versus the traditional inductors. The advantage of code layout is to prevent the material shortage, so when the TLVR inductor is not available, we can still use a traditional inductor. TLVR is a 4-pins output, and the traditional inductor is a 2-pins output. So on the PCB layout, we'll be using 4 pins, and we could always switch to traditional inductor by using the pin 1 and pin 4 only for in case. The following is a 3D video to further explain the code layout function. It is now time to show ITG solutions for TLVR topology in current 5x6mm power stage market. ITG provides 12x6mm footprint and a smaller 9.6 by 6.4mm footprint with height up to 12mm for different designs. As for future 4x6mm power stage requirement, ITG also offers our best solutions of 4.7mm to 5.0mm with TLVR inductors for flashing. This is a page of compensation inductor LC solutions offered by ITG. LC is functioning to control the ripple current. With a lower inductance LC, there is a higher ripple current and ripple voltage. This will lead to increasing the transient response speed. In the other way, with a higher inductance LC, it will lower the ripple current and the voltage, which will lower the transient speed also. ITG offers different materials of inductors for LC requirement. Ferrite materials will be used for higher current, lower DCR with taller heights of the inductors from 8mm to 11mm. This is usually using on the front side of PCB. ITG also offers powder iron inductors with shorter in height of 3.0mm down to 2.4mm or lower. They are mostly lower current and higher DCR and being using on the backside of PCB. This is all for ITG TLVR introductions. If you have any further questions or need TLVR inductor supply, please feel free to contact ITG. Thank you for your watching.
If you are interested in additional technical information or reviewing product datasheets, please visit our website at www.itg-electronics.com. Make sure you register to stay up to date on our latest products and innovations. Thank you for watching. Have a great day.